Hello friends, it's your old pal Mr. Cook. We're doing the second page of the Unit 2 Part 1 group work. So this is the home stretch. We're doing, let's see, number 13 is a graph and answering some graph questions, and then number 14 is a word problem and answering some of those word problem questions, you know, looking for the vertex, the X-intercept, the Y-intercept, that kind of stuff. So with a graph, just make sure to, to graph it out on your graphing calculator so you can find a bunch of nice stuff that goes along with it to make sure it's a pretty accurate graph. We need to find the vertex and the intercepts algebraically. That's really, really easy to show. We've been practicing it all, for the past week and a half, 2 weeks. And then write the equation in standard form. So standard form in the textbook and by extension the group work that we have is really just a fancy way of saying vertex form. That's what we're looking for there. So it'll look like this: y equals a times x plus h squared plus k. And I will do that, but this requires completing the square. If you've been paying attention, you know that completing the square is not one of the things that we're going to be testing on. So I'll do this, but it's not something that you really need to know for the test. So anyways, we have our expression. We need to find the vertex and the intercepts, the x and y intercepts. And remember that a vertex and also the intercepts are just coordinates. So we need an x and a y value for those particular values. So we have our equation written up in standard form. Finding the vertex is really easy, so let's get that one first out of the way. So vertex in standard form, you find the x value first, then the y value. The x value is really, really easy to find. It's just the negative b over 2a. So a, b, and c are all those same things that we had from standard form. So the a value is equal to -1. It's the number on the x squared. The b value is equal to 4. It's the number on the x. And then the c value is equal to 2. That's our constant value. So plugging it into the formula, we get negative b, so negative 4 over 2a, so 2 times -1. So we get negative 4 over -2, which is just simply 2. So that means that the x component of our vertex is 2. Let's find our y component. So to find the y component, all that we need to do is plug the x value back into the original equation. So if we're going to do that, let's plug it in. So f of 2 is equal to, and then we plug it in, negative of 2 squared plus 4 times 2 plus 2. All right, so 2 squared is 4, so we have a negative 4. 2 times 4 is 8, so plus 8, and then plus 2. 2 plus 8 is 10. 10 minus 4 is a positive 6. So our y value is 6. All right, we found the vertex. Let's find another coordinate. A really, really easy one to find is the y-intercept. Let's find that one next. So the y-intercept, all that you need to do is remember that the x value is always 0, and then find the y value. You can plug in 0 here if you want. 0 squared is 0. 4 times 0 is 0. So 0 plus 0 plus 2 is 2. Or you can just simply remember, whenever it's in standard form, that the c value, the last one, is always, just going to be the y value because the other ones get eliminated. So it's a real easy coordinate to find, 0, 2. When we have our vertex and our y-intercept, we can actually start graphing this out pretty accurately, just because of the fact that we'll have an axis of symmetry that goes through the vertex. So I'm going to graph out the vertex, 2, 6, so go over 1, 2, and then up 6, 1, 2, 3, 4, 5, 6. There's our vertex, and through the vertex you get a vertical line that gives you the axis of symmetry, and this axis of symmetry acts like a reflecting line. So any coordinate that's over here on the left gets reflected over here on the right. So if we have a coordinate like 0, 2, so 0, 2, or y-intercept, we can actually reflect it over this line. So if it's 2 away, it's going to be 2 more, so it's going to go 1, 2 over to here. And you can probably already see the downwards facing parabola that's right there. And, that's just the start of your graph. You can actually, from here, graph it out. You could even do this at the beginning if you just want to get the graph out of the way. You can, plug it into your calculator. In this case, it's negative x squared plus 4x plus 2, and zoom 6. And there's my graph. Okay. I'm going to graph out a couple more accurate points to make it look a little bit closer to this. So I hit second graph to bring up the table. And then from the table, I can start, graphing out whatever coordinates I'm comfortable graphing out here. So let's see, -1, -3. So if I go to the left 1 and down 3, 1, 2, 3, there's another coordinate, and I can, reflect that over the line also. So let's see, that puts me another 1. There we go, and then that'd be down to -3, so right there. And that's, pretty accurate, 5 points for my parabola. So it's going to look something like this. And that's pretty accurate to how it's going to look. Getting 5 points, 3 points, something like that. That's enough. Now let's find the X-intercepts. The X-intercepts, I always wait till the last, to find it because, it takes a little bit of intuition to find these values. So you can either factor or use quadratic formula. So depending on your strength in factoring, you could try to factor it first. If that doesn't work really fast, just go right into quadratic formula. For me, I know that this won't factor because there's no numbers that multiply together to be -2 and add together to be 4, no integers that do that. So instead, what I'm going to do is just jump right into the quadratic formula. I've already labeled A, B, and C, so I plug it into the formula. The negative of B, so 4 plus or minus the square root of B squared, 4 squared, minus 4 times A, which is -1, times C, which is 2, all over 2A, so 2 times -1. So we've got -4 plus or minus the square root of something over 2 times -1, which is -2. So that something is, let's see, 4 squared is 16. -4 times -1 is 4. 4 times 2 is 8, so plus 8. So that's going to be 24. So these are going to be my X values for my X-intercepts. Let's try and make these a little bit nicer because I know I can reduce that square root of 24 pretty easily. So square root of 24. 24 is really like saying 4 times 6. And if I take the square root of that, I can take the square root of the 4. That becomes a 2. And I'm left with the 6 inside. So 2 radical 6 is what this reduces down to. So that means that it's going to look like this so far. -4 plus or minus 2 radical 6 over -2. So I can reduce this a little further because I noticed that -4, -2, and 2 are all divisible by 2. But I'm going to take it a step further and divide everything by -2 instead. So if I divide everything by -2, this -4 turns into a +2. This 2 and this -2 reduce down to a +1 or -1. But see, the plus or minus actually stays the same because if I have a +2 divided by -2, I get a -1, which would be the negative part right here. And if I take the -2 and divide by -2, I get a +1, which would be the positive right here. So even though I'm dividing by a negative, this plus minus actually doesn't change. So these are my two X values. So if I write it out as a coordinate, it's pretty easy. It's just 2 plus the square root of 6, 0, because that's how X-intercepts look. The Y value is always 0. And then my other coordinate would be 2 minus the square root of 6, 0. So these are my two X-intercepts. This is my Y-intercept, and here's my vertex. So I've got all of those parts pretty easily graphed out. And then if they want me to label my intercepts, I've got X-intercepts there, they're approximately there. My Y-intercept here, my vertex here. Now let's write it out in standard form real quick by completing the square. So this is a process that doesn't take very long, but it's just kind of unnecessary since we're not going to do it. So just fast forward ahead till I'm done with this if you don't want to pay attention to the completing the square part, but I'm going to do it anyways. All right, so I've got y is equal to -x squared plus 4x plus 2. So I move the constant value over, so I've got y minus 2 is equal to -x squared plus 4x. Now I divide out, or I factor out the lead coefficients, so I've got y minus 2 is equal to -x squared minus 4x. Then I take the b value and I divide it by 2. -4 divided by 2 is a -2. So I get negative of x minus 2 squared is equal to y minus 2, and then I add in the constant value, which is going to be -2 squared, and then I also have to put that lead coefficient up front, so negative. -2 squared is 4. The negative of 4 is going to be -4, so I have -4 plus y minus 2 is equal to negative x minus 2 squared. And then -4 and -2 makes a -6, so y minus 6 is equal to negative of x minus 2 squared. And then I just move the 6 over, and I'm in vertex form. Y is equal to negative x minus 2 squared plus 6. So that would be the expression written out in vertex form. All right, now we move on to the word problem. This is actually a pretty easy word problem. It says a cannon is shot upward from on top of a cliff with a 100-yard drop to the sea. The cannon has an initial speed of 32 yards per second. The height of the cannon, h of t, so that tells us what the h of t part of it is. That's the y value, essentially, is height. And then with respect to time t, so t is the input value, so that's going to be our x value, time, and it's modeled by the following function. So another thing you got to watch out for is the units, and if we're talking, if we just even have this velocity here, it gives us the units that we need. The height is going to be in terms of yards, the time is going to be in terms of seconds. That's kind of a cheap way to get those units pretty easily. All right, so we have this equation over here. We're going to use that pretty regularly when we're looking through our word problem. But first, let's make a sketch of the situation. So we know that the cliff is 100 yards above the sea, and then we've got like a cannon. So maybe the cannon, you know, like that, and then kind of crappy looking cannon. I'll try and work on it a little bit. Then the cannon fires, you know, it's a little thing with the flame. It fires the projectile into the air, and then it finally rests in the sea. Perhaps there's some sort of monster under the sea or something like that it's trying to attack with the cannon, who knows. And then from here, we can kind of evaluate all the key points that we need from the graph that might show up in the word problem. Like where it originally shoots from, that's going to be, you know, the y-intercept, because that's where the whole graph starts. It's the initial point for, you know, for where the graph begins. At the top point, this maximum height over here, that's going to be the vertex. And then where it hits the ground or hits the ocean in this particular point of the sea is going to be our X-intercept. All right, now remember some of these things. For example, the y is the height, so that's going to be in terms of yards. And then the x values are going to be in terms of time. So X-intercept is going to be in terms of time, and that's in terms of seconds. There we go. So it looks like we have everything that we need to answer some of these questions. Even got a cool little diagram drawn out too. So let's see. It says, how many seconds until the cannon reaches its maximum height? Well, if we've paid attention while we've been working on word problems, we know that maximum, minimum, greatest, least, you know, those kind of things, those words imply that we're going to be looking for the vertex of this particular graph. And if you look a little closer in this, it says how many seconds until the ball reaches the maximum. So this is actually looking for the x part of the vertex. The second part of it says what's the maximum height. So they're actually looking for the real height, which of course is the y value. So we're just looking for the vertex. The first question answers the x part of it. The second question answers the y part of it. So let's find the vertex. This is in standard form, so we still use the same rule to find the vertex. The x value is equal to negative b over 2a, so we plug those two values in. Our b value is equal to 32, so negative of 32 over 2 times a. A is negative 16. So we get negative 32 over negative 32, which is just simply 1. So the first part, the question says, how many seconds until it reaches the maximum height? It's just 1 second. That's it. Now we look for the actual maximum height. So what we do is we take that x value and we plug it into the equation. So h of 1, the height at 1 second, is equal to negative 16 times 1 squared plus 32 times 1 plus 100. All right, so 1 squared is 1, so negative 16 is what we get there. 32 times 1 is 32, and 32 minus 16 is 16. So we get 16 plus 100, which is 116. And remember that the units for height in this case are yards, so it's 116 yards to answer that second question. All right, now for the third question. At what time will the ball hit the water? So when it hits the water, or if it hits the ground, or if you want to calculate the hang time or how long it's in the air, this is always just looking for the x-intercept, okay? Those key phrases show up so often. That's why I'm able to kind of point out, you know, this key phrase tells me exactly that it's an x-intercept. It's because I've seen it a million times in word problems. So, you know, just look for those connections, and answering word problems can be a piece of cake. If you make those connections. At what time will the ball hit the water? So finding the x-intercept, I'm not going to waste my time trying to factor that. Whenever I have a bunch of numbers that I'm not very familiar with, like, you know, I don't know all the factors of negative 1600 off the top of my head. So what I would do is just go straight into quadratic formula, because that's one of the key ways that you solve for the x-intercept, quadratic formula. All right, so here we go. My a value is negative 16, my b value is 32, my c value is 100, so I use the formula. negative of b, 32, plus or minus the square root of b squared, so 32 squared, minus 4 times a, which is negative 16, times c, which is 100. All over 2 times a, which is negative 16. All right, so that gives us negative 32 plus or minus the square root of, I don't know yet, over 2 times negative 16 is negative 32. So let's figure out what that is. And one of the nice things about writing this stuff down in parentheses is that if you translate this into your calculator, you can actually find like the exact value for that. So I'm going to do all this stuff underneath the square root and figure out what that number is. So let's see here, we have parentheses 32 squared minus 4 times parentheses negative 16 times parentheses 100. And if I type that into my calculator, I get 7,424. All right, so this gives us two possible answers for x. We have negative 32 plus the square root of 7,424 over negative 32, and we also have negative 32 minus the square root of 7,424 over negative 32. So we have two possible answers. Let's find out what they are, actually calculate them and see how that fits into the context of the question. So we're going to type this in first. Since I've got two numbers adding on a fraction, I got to make sure that I have parentheses around the top. So parentheses, and then we've got, let's see here, negative 32 plus the square root of 7424, and then divide that by negative 32. And hit enter, and we get negative 1.69. Okay, I'm just going to round it to the hundredths place. Now I'm going to do this one as well. So I've got negative 30, parentheses, negative 32 minus the square root of 7,424 and parentheses over negative 32, and I get positive 3.69. So remember that these are X-intercepts, so we're using the X units, which is time, so seconds. So it's either going to be negative 1.69 seconds or 3.69 seconds. One of these is right, one of these is wrong. Just answer the question. At what time will the ball hit the water? So if I told you negative 1.69 seconds, that wouldn't make any sense, right? It would only be the positive answer that I'd want. So this is going to be the one that I want as an answer for this word problem, 3.69 seconds. All right, so that completes the second page of the group work review. Remember, if you have any questions, don't be afraid to reach out to your teacher or just come by in the morning and get some help. All right, good luck studying and good luck on the test.